We need 1.6 million items during a year. Preparation for each run is $400.20 to store each item. The inventory cost model is going to look at the number of items that we make per run. And that's going to be our variable starting off. So if we make 5,000 items in each run, I need to know the number of runs that would be needed. I need to make 1.6 million items. Let me lock that reference in place. And if I make them 5,000 at a time, I would need 320 runs. So the prep cost to do that is $400 per run. Lock that in place. And 320 runs, 128,000 in prep costs. Okay, now the items in storage. Mathematically, at any given time, half of the run would be in storage, sometimes more, sometimes less, but on average, half. And then the storage cost is 20 cents per item, lock that, for each of 2,500 items. It's $500. And then the total cost is storage and prep. Okay. Now the question is, what if I make bigger batches? So if I do twice as many items per batch, I only need 160 runs. My prep cost went down by 64,000. My storage cost doubled, but overall total cost went down. So let me look at different options here. So the bigger the batches, the fewer runs needed, lower prep costs, but more items in storage. So storage cost is going up, prep cost is going down. Total cost so far is still going down, but see how it's getting less? It means I'm getting close to the optimum here. Let me graph this against total cost. Okay, now eventually, let me change this item. If I do 200,000 items in each run, now I only need 8 runs. So my prep costs are really small, but now there's a lot of items in storage and my storage costs have gone up. And overall, the total cost is higher for this big batch size than it was over here. Okay, so let's figure out what the optimum would be. So I can fill in total cost for 5,000 items was 128,500. Total cost for 200,000 items down to 23,200. But now when would it be minimized? So let me pick a row to use for the solver. I'm just going to use this top row. And to pick a pull-up solver, I want to set the total cost to a minimum by changing the items per run and just have positive numbers of items. 80,000 is the most economical, and that's right there. What is the minimum cost? 16,000.